Dear students, in this video we are going to study parallel plate capacitor, but parallel plate capacitor inside of which we placed a dielectric medium. For example, if this is a parallel plate capacitor, if this is a parallel plate capacitor with charge Q minus Q and a distance of d between the plates, surface charge density sigma, electric field inside is E0, like E, electric field. Now what we'll do, in the previous case, the medium inside the parallel plate capacitor was vacuum, but in this case the medium inside the parallel plate capacitor will be a dielectric. So this is not a vacuum, but we place a medium inside the parallel plate capacitor, and we will see what will be the changes on the capacitance of the capacitor. So the new medium between the plates of the parallel plate capacitor is a dielectric medium whose dielectric constant is K. So what we did here is we placed a dielectric medium inside the parallel plate capacitor. So the topic will be effect of dielectric in parallel plate capacitor. Effect of dielectric in parallel plate capacitor. So previously, when there was vacuum inside the or between the parallel plate capacitor, then vacuum between the parallel plate capacitor, in that time our electric field inside the capacitor was sigma divided by epsilon 0, so that voltage in between the parallel plate capacitor, or potential difference between the parallel plate capacitor, was E into D, which was sigma by epsilon 0 into D, which will give us sigma is Q by area, so it is D by epsilon 0. This was our voltage, like in different way we can write this in different ways, Q into D divided by A epsilon 0, such that our capacitance was Q divided by V. So capacitance was basically Q divided by Q into D divided by E into epsilon 0. So here Q get cancels, such that my capacitance was A epsilon 0 divided by D. So this was the capacitance of the capacitor. A epsilon goes up, so D is in the denominator. So this was the capacitance of the capacitor when there was vacuum between the parallel plate capacitor. Okay, so for such things, because I want to calculate the capacitance of the capacitor now when there is a dielectric medium between the plates. So for vacuum I'll give a different notation, E0 for vacuum, V0 for vacuum, so C0 for vacuum. Q is Q, so V0 for vacuum, so C0. So V0 is the potential difference between the plates when vacuum was between the plates. E0 was electric field between the plates when there was vacuum inside the plates, and C0 is the capacitance of the parallel plate capacitor when there is a vacuum between the plates. But when there is a dielectric medium, now what will happen is, when there is a dielectric medium between parallel plate capacitor. Now what will happen is your electric field, new electric field will be decreased by rate K, or where K is the dielectric constant, where K is the dielectric constant of the dielectric medium. So it is dielectric constant. So it is reduced by a factor of 1 by K. Electric field get reduced by a factor of 1 by K, such that new potential will be E into D. So it is also reduced by a factor of 1 by K. Similarly, capacitance will be okay, E0 is your sigma by epsilon 0, but E0 also get like E0 is your okay, I can write E0 as further E0 as sigma by epsilon 0. There is 1K, so K. So E0 is sigma by epsilon 0 into K into D. Okay. Yeah. E0 is sigma by epsilon 0. There is 1K, so that K is goes there. So E0 is sigma by epsilon 0. There is 1K, so K is here. So sigma into D, K into epsilon 0 is your new potential. Similarly, your new capacitance will be Q divided by V. So this will be equals to Q divided by your new potential is sigma into D divided by K into epsilon 0. But this sigma is actually Q by area into D K into epsilon 0. Here Q get cancels. So your new capacitance will be K into A into epsilon 0 divided by D. That means when there was vacuum, my capacitance was A into epsilon 0 by D. This was my previous capacitance when there was vacuum, A into epsilon 0 by D. But in this case, our capacitance is K into A into epsilon 0 by D. That means capacitance increases by a factor of K, where K is the dielectric constant of the medium. Dielectric constant of the medium. That means here capacitance get increased by a factor of K. So our new capacitance will be A epsilon 0 into D is C0. So A epsilon 0 divided by D is my C0. So C can be written as K into C0. So this is my old capacitance when there was vacuum. This is my new capacitance when there is a dielectric medium. So from this we can write K is equals to C by C0 also. K can be written as C by C0. So this is very, very important relation. C is equals to K into C0 is a very, very important relationship. So this much for today. Thank you.